Okay, physics friends, today we're going to look at another equilibrium project problem, but this one is one object, but it has two strings. So with two strings means I have two different tensions, and I am interested in knowing what the tension in each string is. What the tension in each string. What is the tension in each string? Okay, so let's start by drawing a free body diagram. So I'm going to draw force of gravity straight down because gravity works towards the center of the earth. And I'm going to draw my force of tension up along the string. I'm going to call this one T2. And I'm going to call this tension here the horizontal string T1. Okay? A couple other things that I'm noticing here. I'm noticing that T2 is at an angle of 43 degrees, which means that there is some tension. A piece of T2 is in the x direction, or T2x, and a piece of that tension is in the y direction, T2y. And I need to keep my x and y separate here. So what I'm going to need to work on is figuring out what those components equal, so then I can either use trig or I can use maybe Pythagorean theorem to figure out what T2 is. Okay? So let's first start looking in the x direction, or the forces that are horizontally here. And so in the x direction, I'm going to look at F net equals ma. And normally I think of helping minus hindering. And so I'm going to say that T1 is helping and T2 is hindering. Okay? And I'm going to say that because T1 is helping hold it against the wall and T2 is trying to pull it off the wall. So I have T1 minus T2 in the x direction, and that's going to equal ma. Is my box accelerating in the x direction? No. So the acceleration in the x direction is 0. So that means this whole term is 0. So T1 minus T2x is equal to 0. Or I can say that T1 is equal to T2x. But that's about as far as I can go. I don't have a value for T1 and I don't yet have a value for T2x. So I'm kind of stuck in the x direction. Well, don't give up. Let's first look in the y direction. Okay? So looking in the vertical direction, or the y direction, I'm going to apply the same F net equation. F net equals ma, and I'm going to think about helping and hindering. What is helping hold the block up in the y direction? Well, that would be my purple arrow here, my T2 in the y direction. And Fg would be hindering or trying to pull it down. So Fg, or the weight, and that's going to equal ma. Is my box accelerating in the vertical direction? No. So A is 0. So T2y minus Fg is equal to 0, or T2y is equal to Fg. Now you might think that you're stuck there too because you don't know the weight or the force of gravity. But remember, Fg is equal to mg. It's equal to the mass of the object times the acceleration of gravity. So I can find out what T2y is. So T2y is equal to the mass times the acceleration of gravity. And so this is going to equal 10 times 9.8. So that means that T2y is equal to 98 newtons. All right, so I have T2y equals 98 newtons, and I have an angle. So maybe I should draw a trig triangle and see if I can figure out what T2 is from just T2y. So here is a trig triangle. And I'm going to label it. here's T2, the hypotenuse. I have T2x on the bottom, and T2y is vertical, and the angle here is 43 degrees. Okay. I know that T2y is 98 newtons, and I want to know what the hypotenuse is. And so if I think about my trig functions, well, the sine of theta is equal to the opposite side over the hypotenuse. And so I can actually use the sine of theta to figure out what T2 is. Okay. So I'm going to use the sine of 43 degrees, and that's going to equal the opposite side, which is 98 newtons, over T2. So to get T2 by itself, I would have to multiply it out of the denominator, and then I'm going to have to divide by the sine of 43. So T2 is equal to 98 newtons divided by the sine of 43 degrees. And when you do that math, you end up with 143.7 newtons. Excellent. All right, well now where do I go from here? That's what the value of T2 is, but how do I get T1? Well, looking back over here, I know that T1 is equal to T2x. Could I use this trig triangle to figure out what T2x is? Yes. And if I know that value, then that's what T1 equals. Okay? So that's what we'll work on right now. Okay? So I'm just going to slide this up just a touch. And let's see. T2x is the adjacent side to the angle. So I know that the cosine of theta is equal to the adjacent side over the hypotenuse. Okay? And so in this case, I'm going to say that the cosine of 43 degrees is equal to T2x over my hypotenuse, which is T2, which is 143.7 newtons. So multiplying both sides by 143.7 to get it out of the denominator, I end up with T2 in the x direction equal to 105.1 newtons. And that's also what T1 equals based on this equation here. And there you have it. You have an equilibrium object with two strings, and you can find the tension in each string.